Hey everyone, this is Derek, and in this video is a continuation of the U-Substitution video. This is just going to be a couple of application problems using that same math. So this first one goes, a worker having no experience with a particular process can assemble 60 units of product each week. After training, T weeks of experience, a worker can assemble at the rate of that. So A, we have to specify N of T that describes the worker's weekly output. So notice they're giving us N prime. So this is they're giving us the rate, and they want us to go backwards. They want us to find N. So that's the bulk of what this problem is going to be, is just trying to get this integrated. So let's get this integrated. So we have N prime of T equals 450 e to the negative 3t. So then I'm going to integrate both sides, so dt, dt. So then the integral of n prime of t is n of t. And then I still have to work out this side. So over here, let me bring that 450 out. And then we have this kind of chunky something other than just a plain exponent up there. So we will I can just use, we have a property for that. Let me show this U-substitution. So, okay, I'm debating whether or not to do it the long way or the short way. Let me show it as a U-sub just because that's what the section's about. But you can also, it's right there, we have this property, but you're sort of showing why this works. So here, oh God, I hate to do all that work. Oh well, okay, I'm gonna do it. Negative 3t dt. Here we go. Okay, so u is going to be the negative 3t. Du is going to equal negative 3 dt. I need that to be not, I guess it's not that much work, but I need this to be dt, not negative 3 dt. So I'm going to divide both sides by negative 3. On this side, I'll think of that as multiplying by negative a third, which is the same thing. So now when I do my substitution, N of T equals 450, and this is going to be e to the u, and then dt is now times negative 1/3 du. So if I bring that out front, that'll make that negative 450 over 3, which is negative 150. And then that is e to the u du. And then integrating, that gives me negative 150 e to the u, and then u was negative 3t plus c. So that is my general form, but this time we have some information about what was happening at t equals 0. So since here we're trying to actually get answers, that means we're going to be given some value that we can find that constant with. And back here it said a worker having no experience, so that means that t equals 0, their output, n of 0, is 60 units. So when t is 0, n equals 60. And what that's going to do is allow me to solve down here. So let me sneak up here with it. And then actually let me cut back here for a second and show I could have right there, I could have also shortcut this and just use my exponential rule, because we do have kind of the souped up version of that with the k. And so if I do 1 over the derivative of this, that would be that same negative 1/3 that I got doing the substitution. So here, let me come back in and get this c figured out. So when t is 0, the output is 60. So that's going to give me a 60 on that side, negative 150 e to the 0 plus c. Because this times 0 will still be 0. E to the 0 is 1. Anything with the 0 is 1. So that's really 60 minus 150 equals c. So I'll add 150 to both sides. And now I got 210 equals c. So my equation will be So that is my part A. Part B asks for find the number of units worker having 60. Oh, actually, you know what? I bet that was supposed to be 6 weeks. Yes, that's supposed to be 6 weeks. I will fix that in my notes. So find the number of units a worker having 6 weeks of experience can assemble. And so I think if you throw a 6 in there, it will still come out to this 210. And the reason is even a 6 would make this e to the negative 18th. And let's see what e to the negative 18th is. On shift, where is it on this one? There we go. E to the negative 18. Yeah, okay, so what that means is that's 1.5, and then that's times 10 to the negative 8th. So it's like there's 7 zeros there. So this is super, super, super close to 0. So what happens for values of t that are remotely large at all is this piece goes to 0, and you're going to get this 210. And where that comes into play is for C, what is the maximum number of any worker can expected to assemble in a week? And it's going to be the same 210, because as this gets large, then this whole term goes to 0, and then it approaches 210, or it is 210. So that's your max. Okay, for this one, medical researcher believes that the human immune system produces antibodies to a particular vaccine at a rate of that. And again, they're giving us a rate, so this is a prime. So when we integrate, that will get us to n. Assume that when no vaccine is administered, the immune system produces no antibodies. So at t equals 0 prior to being introduced, then n is 0. That doesn't mean c is 0. That just means when t is 0, the output is 0. So specify the function that describes the antibodies. That's where we're going to find n of t. And then after we do that, we'll figure it out after 8 days. So here we'll integrate both sides of this. Actually, before I do that, maybe while I do that, I'm going to factor that denominator a little bit. So I can take a 5 out of there. And then what that's going to let me do is just reduce that down to a 1,000 up top. So it just gets kind of a common factor out of the way. So here we'll have n of t equals, I can bring the 1,000 out front. And so then this is a 1 over situation. So remember with our 1 overs, that is going to be our natural log. So here we'll have u equals t plus 2, and so then du equals dt. So here we'll have 1,000 times the, let's see, natural log of t plus 2 plus c. And so then, like what I was saying earlier, is that just because this is 0, 0 doesn't mean c is 0. So you have to be a little careful with that. So let me go ahead and toss this 0 in here now. So I have n of t equals this equation. So I'll just slip a 0 right there. And then 1,000. And then ln of 0 plus 2 would be 2 plus c. So then when I slide that over, c is going to be the negative of this. So c will equal negative 1,000 ln 2. Once I got that, so let me write out my whole equation here. Okay, so there's our n of t. So coming back here, just to show where that came from. So I did my integral, and then we got this piece, and then c was this negative 1,000 ln 2. So I just drop that on the end. So that's the function. And then find the number of antibodies produced after 8 days, round to 2 decimals. So I'll show you what I put in my calculator. Okay, so right here, for this t, I just put in 8, and 8 plus 2 gave me 10. So we're doing that calculation, and 2 decimals, I got 1609.44.